Right. So without further ado, I'll just do a really brief introduction to Ubisense, an introduction to the technologies, and then what I've got is a bit of a smorgasbord of the different kinds of applications that we deliver into customers using our technologies. And really this, it's intended as a bit of a food for thought about how Lilium would like to, start looking at the technologies to support all the kind of complex processes that you will have in place around your manufacturing operations. So Ubisense is not a new business. We're not new to the Industry 4.0 or IoT space. We've been around since 2002. We're a British founded company. Our headquarters is still in Cambridge in the UK, and we were one of the first companies to start using ultra wideband location systems to deploy site-wide, factory scale, location systems. But interestingly, we were not founded as a hardware company. We were founded as a software company to build, technology that at the time. So the four founders of the company are still with the business today. And the research they were doing at Cambridge University was around what they called at the time sentient computing, which in modern parlance is probably most akin to what people call digital twins, building a software-defined virtual model and representation of a facility or an environment, and driving that with sensor data, predominantly location information that would allow computers to understand what was happening in the real world, and then for support human activity, everything around what humans are doing in environments. And at the beginning of the company, we didn't know that we would end up focusing or having a core focus on manufacturing. We tried to take this technology down many different avenues, but it was really in 2008 when we landed our first large manufacturing contract with BMW in Regensburg, which is one of Uber's customers, that we pivoted the company to having a core focus on manufacturing. It was also around that same time that we were working very closely with Airbus, and we ended up doing a large number of rollouts in parallel across the automotive industry into the likes of BMW and Daimler and VW, as well as into Airbus. We ended up doing, and I'll talk about this use case a bit later, but deployments across the whole of the A380 program, into the A350 program and the A400M program. Along the way, we've also formed strategic partnerships with the key tool manufacturers for assembly operations. The first of which was Atlas Copco in 2010. And we've had an interesting journey in terms of ownership and investment over the years. We were a publicly listed company for a while, from 2011 up until 2019, where we were acquired once again, delisted off the London stock market, and we are now private equity backed. Along the way, we've picked up other, really household names, and I'll talk about that in a little bit as well. But you can see that we're a mature business. We're widely deployed. We have operations across the major kind of economic territories where manufacturing happens around the world. So USA, the UK, France, Germany, and Japan. And the technologies we deploy are prevalent in many of the big names in automotive and aerospace. And we're proud to say that more than 5 million of the world's vehicles are built every year, which fundamentally rely on our technology to actually complete their assembly processes. And just to give you a flavor of the customers that we're working with, I'm sure you'll recognize every one of these names on this list. So we deploy big enterprise scale systems into these customers to help them with their manufacturing operations, and the kinds of things we do with them you'll see in all the use cases that we'll cover today. Now, while we have a focus on manufacturing, particularly automotive and what we call CVAM, commercial vehicles and agricultural machinery. So John Deere is another big, enterprise customer. We also, the technology is sufficiently generic in terms of what it does that actually it's applicable in many other industries as well. And we work across not just the manufacturing side of aerospace, but also the maintenance, repair, and overhaul of aircraft. We work in health sciences and pharmaceuticals, electronic and appliances assemblies, many different logistics scenarios, and even people tracking across things like worker safety and even in the entertainment industry. So just as an interesting anecdote, if you ever come to London and you go to the West End or some of the big shows in other parts of the world like Vegas, there are many of the shows that actually use our technology to control the lighting and the directional audio so that it feels like what you're hearing is coming from the performers on stage. So some really neat stuff that some of our partners do with our technology in the entertainment industry. But what are the core problems that most of these customers are trying to solve? It's all the things that come with modern manufacturing processes where you're trying to achieve high degrees of customization and variation. There's a push for greater degrees of flexibility in your assembly processes, and those things are often, compared to the old Model T Ford type assembly line, they can have a negative impact on your ability to maintain quality, your ability to optimize your productivity. They create more complexity, which obviously has a knock-on impact on those things. And this obviously overall has an impact on your costs. And so these are the core drivers for why customers care about using Ubisense in their environments. So what is it that Ubisense offer? So first and foremost, as I say, we're a software company, not a hardware company. And our smart space platform is a technology that we've been developing since 2002. And it is fundamentally a platform technology that allows you to build many different kinds of location-aware applications that support various kinds of operational processes in your factory, always around how things are moving and interacting with each other in a process. And what we provide with the platform is a set of building blocks that we as Ubisense or our partners use to build these kinds of location-aware applications. And the really kind of key thing to note, and we'll talk a bit more about this, is that Smart Space as a platform is also sensor agnostic. So while we have our own ultra-wideband real-time location system, which I have mentioned and we'll talk a bit more about, Smart Space is intentionally an open platform, which means that we can integrate any location or identification source into the platform and use the right sensor to solve the problem that you are working on. And usually that's either a single sensor or very often actually a combination of sensing technologies to get you the best combination of performance and cost benefit for your solutions. So Smart Space, as I say, is a sensor independent or sensor agnostic platform. It's very proven in industry, and we built it from the ground up to be enterprise scalable. So you can take the same platform technology and deploy it very large to solve a set of problems in a department, or across multiple departments, solving lots of different problems in different departments, all on a common platform. We've built the system for mission critical reliability. So as I say, you go to the automotive industry where we're doing hundreds of thousands of control events every day in every factory to build all these cars. And we have to be able to achieve actually better than 6 sigma reliability, so better than 1 part per million error rate in the control information that we're feeding into the overall control system or directly down to tools that are being used on the assembly line. And so the combination of being built for mission critical reliability and having done it for a long time has also meant that over the years we've been doing this, we've also built not just the functional components of the system, but also the advanced IT components that mean that you can run these systems at scale, that you've got minimal downtime. You can manage and adapt those systems over time to, to adapt to the changes in your production environment as well. So again, I'll keep pointing at Uwe. Uwe is, our account manager for BMW. That Regensburg plant has been running since 2008. And we've made additions to that plant since 2008, lots and lots of additions, but it's basically been running 24/7 since 2008 with add-ons over time. And that kind of shows you the long-term, reliability that you get with a system like this. So in terms of, what's in the box, as I say, SmartSpace is a platform. It's a modular platform, which means we've got lots of different components that we configure. So it's a low-code platform technology that we configure all these different components to do lots of different and interesting things. And I won't go into any more about that now, because it's much easier to see the kinds of things that we do later on. But as I say, SmartSpace is a sensor-agnostic platform, which means that we can bring in all of the right technologies to solve the problem at hand. And that means that we're working on a daily basis with technologies like GPS, bringing in identification technologies like barcode and RFID. We work with Bluetooth low energy technologies, either a combination of beacons or best-in-class real-time location systems using angle of arrival. So Quipper is our preferred partner, for example, for BLE solutions. And we have our own ultra-wideband real-time location system, which is the technology of choice if you're trying to solve very hard location problems, which we'll see some of those in a minute. And we even work with vision technologies, because sometimes radio-based location, even as accurate as ultra-wideband is, can't get you down to solve some of the very granular problems that you need to solve. And actually, we can bring in other technologies and overlay them on top of these, radio-based sensing technologies to achieve some other interesting results in terms of problem solving. Please stop me anywhere along the way if there's anything you want to ask. So as I say, Ubisense has our own ultra-wideband real-time location system. So as I said, back in 2002, 2003, when we founded ourselves as a software company, we needed to drive this the software capability that we were building. We needed a very high precision, industrially resilient location system. And we went to market to look at, who was on the market providing, because we picked ultra-wideband, because ultra-wideband really has all the right characteristics for providing high precision and high reliability. But there were only two vendors on the market at that point in time who were trying to license their technology. One was called MSSI and one was called Time Domain. And MSSI and Time Domain were not deemed to be ready yet when we were talking to those companies. And so we basically went off and built our own ultra-wideband location system. Fast forward to today, Ubisense is one of only 3 companies in the world that own their own intellectual property around ultra-wideband. There's Ubisense, there's Zebra, who acquired MSSI. So you've probably all heard of Zebra. And then there's a company called Decawave, who've recently been acquired by Qorvo. And you may not have ever heard of Decawave or Qorvo, but all the other ultra-wideband providers on the market today, unless they're Ubisense or Zebra, are using a Decawave chipset inside their system. And there are different flavors of those Decawave-based systems. Some are better than others. But really, those are the three main providers on the market today. And Ubisense's offering around ultra-wideband is differentiated from all those others as well. We're the only company to do what's called both angle of arrival and time difference of arrival measurements in our ultra-wideband system. And the reason that's important is that for every sensor, this box you can see here is a sensor. It's basically a radio receiver that does a lot of clever onboard processing. It's the only sensor technology that's able to measure both angle of arrival and time difference of arrival. And the reason that's important is it means that we get a lot more measurements of the emitted ultra-wideband signal from every tag And the reason that you need that more measurements is important, and I'm sure you'll know this from working with onboard systems and things in your own aircraft, is you need to turn measurements and sensor information into an understanding of what's happening in the real world. And when you have an oversupply of measurement information, you can get a much higher confidence result of the thing that you're measuring. And so in a like-for-like environment, Ubisense requires less sensors, and it can achieve higher levels of reliability with our ultra-wideband system to solve these very, very challenging tracking problems in industrial contexts. So, just a quick table, and I'm not going to jump into this today because we can always circle back on this at a later date. But there are a spectrum of technologies that are appropriate for different purposes, and Ubisense works with all of them, including we work with other ultra-wideband location systems. Where a customer may have already bought one of those technologies, and they're wanting to put software capabilities on top of that to actually utilize the location information. We also work with Bluetooth low energy solutions where it's appropriate and where it's solves the problem for the customer in the right way. And we do a lot these days with barcode and passive RFID combined with things like ultra wideband and Bluetooth. And when we're looking at outdoor wide area type tracking, we often use GPS because it gives you, again, the best kind of cost benefit in terms of coverage, but the accuracy of GPS is not particularly great. So again, it really comes down to what kind of a problem are you trying to solve. Right, so any question about technologies before we head into the more interesting stuff? And am I speaking okay? I'm not going too fast.
Doesn't sound like it.
Okay, very good.
I told you, they're all the smart kids. You have to go slow for me.
All right, well, Andy, if you've got any questions, stop me along the way. All right, so I'm going to go through a bunch of different use cases. This is actually not an exhaustive list. I think this is the stuff that when I spoke to Andy a couple of weeks ago, he said, these are some of the ideas that, may be interesting to yourselves. So, by all means, if you've got things that you're thinking about, let's chat about those as well. And there's probably other stuff that we can put on the table at a later date as well. So I'm going to start by talking about process control use cases. This is the kind of thing that we talked about that we started doing at BMW all the way back in 2008, and you can see how you'll see how some of those core concepts have expanded out into lots of different ways of using the technology to support assembly control. So let's talk some fundamentals. What are we actually talking about when we talk about smart space and location systems and this kind of thing? So if you imagine a typical, car assembly line, I've got a conveyor-based system, bringing product down a line. You've got operators on the side of the line that are picking parts, fitting parts. They've also got a lot of handheld tooling, DC, powered nut runners and things like that. There's obviously, and I'm sure you're well aware, there's been a trend in the industry over the last, really over the last 10 years. It hasn't picked up as fast as I think anyone had imagined, but to push towards battery-powered tooling, and that's great in terms of ergonomics and reduction of damage related to tool tethers and things like that. Paint marring, but it means that you've got some challenges around actually ensuring operators are doing the right thing with the tool in the right place. So this was one of the fundamental motives for BMW back in 2008. One, they actually wanted to get rid of barcode scanning because they were doing a lot of manual identification on the line, but they also wanted to be able to better control how tools were being used on the line. And so the core principles behind how we solve this problem in an assembly context is we put Ubisense ultra-wideband tags onto the product, i.e. the car or the engine block or whatever it is coming down the line, and onto the tools or into the tools, which we'll see in a minute. And the other core idea is that we deploy our sensor technology across the environment. And in an assembly line environment, that means we're spreading sensors down the line. but sensors can be deployed anywhere and everywhere. So you can cover your logistics halls, or sorry, your logistics aisles. You can cover the lines. You can cover bigger halls, because I'm sure your environment is probably more like a typical aerospace facility than a car production line. But really, the sensors can go anywhere that you need them to. And what that gives you is, ubiquitous location. Every inch of air in the facility is suddenly now location enabled. And that means that you can, with tags on things, you can see precisely where they are. And that means you can do some clever things in terms of controlling what's happening in the environment, or monitoring what's happening in the environment. So those tags emit radio pulses. In the case of ultra-wideband, that's ultra-wideband radio. We're not going to go into today why ultra-wideband is special. We can save that for another conversation on another day. But it means that you get a precise 3D location using the Ubisense system. So this is another differentiator of the Ubisense system, is we provide a 3D coordinate, not a two-dimensional coordinate. And location on its own is not actually very interesting, because when you've got several hundred cars coming down a line, and you've got several hundred tools, and we do location updates on these tools, 8 to 12 hertz. We've got a lot of location data being generated every second. So another one of Uwe's customers, or plants, BMW Dingolfing, we're generating more than 10,000 location updates every second in that plant. So how do you turn 10,000 location updates in a second into something that's actually interesting at a process level? And this is where the name Smart Space comes from, because what we do is we build up a virtual model of the whole environment like this, virtual objects, and we don't think about tags, we think about objects, car objects, tool objects, material objects, and we associate with those objects, we give them what we call spatial properties. These are software-defined virtual zones that are either static in the environment or actually attached to the objects. And so wherever the objects move, these zones, it could be one zone, it could be 100 zones that all mean something different at a process level. These are attached to the objects and they move around in the environment. And now, when the tool moves into the zone of the vehicle, we get a very reliable control event, a handshake event, to say these two objects are now interacting with each other. And that means that we can filter out those 10,000 location events and say, okay, in this very second, there were actually only 5 or 10 handshake events that I care about at a process level. And now I can use that to actually do interesting things to control the tools and other things in the environment that I'm tracking. So we've taken that core concept and we've done lots of different things with it in the assembly environments. Over the years, as the big automotive manufacturers like the BMWs, the Daimlers, the VWs, the General Motors, Toyotas, etc., have deployed this technology, we have worked closely with the different, the leading tool manufacturers in the market. And by far, our closest relationships and the most common deployments of this technology have been with the likes of Atlas Copco and Apex, but we also work with Dasuta, Clico, and I always forget the name of, there's a Japanese manufacturer. These are the most common ones that we come across in the market and we work with. And when I say we work with them, you can actually buy our ultra-wideband tag module, which is the core technology we use inside our own tags, integrated into the tool as well through these snap-on enclosures. And so we've been doing that with Atlas since 2010, and Apex and Dasuta and others, since then. But there's also the ability to retrofit a standard Ubisense tool tag directly onto the tool, so you don't have to have the integrated option. The benefit of the integrated option, of course, is that because these are battery-powered tags, they're drawing their juice off of the tool itself, rather than a battery that's part of the Ubisense tag enclosure. But batteries are replaceable, and they last, several years in this use case, even if you are just using the retrofit approach. And so we combine that location information from tools and cars and whatever else we're tracking, and we create these software-defined spaces that allow you to do these really interesting things around process control. And this means that you get unprecedented flexibility in the way you can design your processes, and you can ensure quality of your processes over time. So this allows us to do things, everything from the very simple, I've got a battery powered tool, I only want it to work in that workstation, so we call that a digital tether, to automatic product identification on the line. You don't need to do any barcode scanning or anything like that anymore. You just walk over with the tool. The tool knows immediately what vehicle it's talking to, communicates that either with the MES or directly through SmartSpace into your tool controllers, and the tool is reconfigured for the right torque and batch size and things like that. We can do sequence control like this. We can do dynamic workstations, and you can even have things like roaming rework. So I'm going to stop talking for a second. I'm going to show you a couple of videos just to kind of cement those ideas. And then if you've got any questions about that, we'll pause for a second. So hold on, I don't sure I shared my audio. So let me just do that quickly.
Wireless tool control from Ubisense creates digital tethers to ensure wireless assembly devices only operate in the correct areas. Wireless tools are fitted with tags that are located by sensors on the assembly line, using highly accurate ultra-wideband technology. Precise three-dimensional tool zones are defined in software, within which the tool is automatically activated for use. The worker can then complete the necessary assembly operation within that zone. The tool is deactivated outside the tool zone to prevent unauthorized use. With Ubisense wireless tool control, multiple zones can be defined and an unlimited number of tools added using the same infrastructure. Tools can be easily substituted, so any maintenance required does not disrupt operations. Wireless tool control from Ubisense, adding flexibility and control.
So what you've seen there is, this core concept around defining, fixed zones and spaces around objects. This is another interesting example because it shows how those spaces don't have to be necessarily static. We tightly integrate with the production planning process, and we can actually allow you to do some other really interesting things around process flexibility as well. Oh, hold on, we lost the video.
Assembly control from Ubisense allows workstations to be defined by software, not physical spaces. Tags are attached to products on the assembly line and also to wireless tools. Sensors on the assembly line track the tag locations using highly accurate ultra-wideband technology. Precise three-dimensional zones are created in software that can be different shapes and sizes depending on the individual product specifications and move with the product down the assembly line. If an assembly task isn't completed, the additional time required based on historical performance can be instantly evaluated against subsequent assembly tasks. Because the workstation is defined in software, it can be automatically extended, temporarily allowing more time for successful completion and preventing unnecessary line stoppages. Assembly control from Ubisense.
So again, I think the key message behind all of that is when you start to think about controlling tools not through physical limits like tethers and limit switches and things like that, where you actually start to think about your assembly environments in terms of the three-dimensional space that your operators are working in and the devices they're using, and being able to control what those devices are doing in that 3D space, you can start to design your processes and your operator activities in a very, very different way. And so in terms of the core kind of architecture of this, these kinds of tool control and process control use cases, we've obviously got a network of sensors that are listening out for tag signals. That's all communicates over a standard Ethernet network to an instance of smart space that's running in your nominated server environment. That can be on-prem. It can also be cloud for certain applications. And then the kind of messages that are generated in smart space, there's a number of ways that we can then actuate control back out to the tool to ensure that it's doing the right thing at the right time. And we do everything from data exchange with the MES to basically just tell the MES the name of the zone and the name of the devices that have gone into particular zones. That's simple information we communicate with the MES, and the MES can be responsible for doing all of the control signals to the tool controller. We also communicate to things like station controllers on the line, which will be doing a similar task if an enterprise-wide MES is not in place. And we can even use smart space to act as the MES to send the right control messages to the tool controller to actually turn it off, turn it on, update the batch size, update the torque settings, all typically over things like open protocol. So you've got, again, flexibility for how you use that information in smart space to do that control loop back to the shop floor. So as I say, we've been doing this particular application that we've just seen for a long time, and that's widely deployed across the automotive industry. Any questions about that before I head on to the next use case?
Yes, I do have a question.
Yeah.
The tagging of the product as itself, it's just a further step in the assembly line, or how would that look like? And at the end of the assembly line, you just take the tag again off, or
yeah. So I'll explain that. So in an assembly environment, like on a conveyor-based assembly line, cars come out of the body shop and the paint shop, and they arrive on the trim and final line. And literally at the point where they arrive on trim and final, there's typically a line-side system, whether that's a PLC or it's the MES or some other shop floor system that knows the ID of the product that's arriving in that first station. And we integrate with whatever that system is to get that product ID. And then the operator basically just randomly picks a tag out of a bin and puts it at the the mounting point, the approved mounting point on the vehicle or the product. And that can be all over the place, right? Because we've got customers doing it in so many different ways. BMW and some plants, they do it in the little hole in the front of the bonnet where the badge is supposed to go. Daimler have got like panels on the side of the vehicle, the protections that the tags are actually mounted on there. Some customers put it on the roof. There's various different ways that you can mount the tag, and really that comes down to your assembly. But what happens is that we also have sensors at that very first station that pick up the tag. Smart Spaces picks up the ID of the product, and then we do an automatic association between those two things. So there's no human intervention other than physically placing the tag at the approved mounting point. And then that associates all the location information to that object with the unique ID that we've pulled in from the MES or from whatever other system we're talking to. And so then that product flows down the line, and we do all of these control processes with tools and other things like you're going to see. And then when it gets to the end of the line, there's an operator process to just literally take the tag and stick it into an approved bin location. And again, we automatically pick up the removal of that tag in what's called an automatic disassociation point. And then we basically, that tag is now free to cycle back to the beginning of the process and be reused.
Okay, understood. Thanks.
Okay. So, as we spent more and more time with customers doing these kinds of tool control solutions, we got to learn a lot more about what was happening in factories. And one of the really prevalent things, which I'm sure many of you will know, in assembly environments is there's still a lot of paper for how things like quality inspections are done, or recording of part shortages and even defects, and paper flows down the line, and often, you know, some of that paper recorded information will be captured into, you know, systems like quality systems, but often, you know, the car comes off the line and has a complete paper-based build log that is the thing that will be stored for many years to come if there's ever, you know, a warranty claim against the vehicle or a recall and things like that. And so, you know, some of our customers have been pushing very hard on getting rid of paper in their factory processes. And so, you know, SmartSpace has provided another, you know, really useful framework for enabling, you know, what Daimler, for example, call their paperless factory strategy. And the core idea here is, instead of a tool that is interacting with the car, you can actually use other, you know, handheld devices like tablets, or, you know, smaller form factor screens that are able to display information to operators and, you know, capture operator input. But instead of just giving them a tablet where they can actually just put information in, we're verifying that the information captured is actually for the product that the operator says they're working on, by using that same location context concept. We tie the device to the product. You don't show anything on the device until the operator is standing in front of the product they're supposed to be standing in. And, you know, the same thing like the tool, even if they're in the wrong workstation, for example, like he might be standing in front of the correct next product, but he might have gone upstream slightly and started trying to do the inspection early. You know, so you can control even down to the tact level what is shown when. And with SmartSpace, we have a very flexible user interface technology, which allows us to build almost any UI, context-relevant UI for shop floor operations. And so what you can see here, and I'm going to show you a couple of other, you know, shots of this capability, is a digital build log that allows you to do everything from quality inspections to recording defects on the vehicle, and even shortage information when you've got a parts shortage. And again, you know, you've got in SmartSpace all of these user interfaces that are completely browser-based, so you can fire them up on any browser-enabled device, and you can start inputting information into the system to record your assembly processes. And that can be everything from, you know, what you can see here, recording defects on the vehicles, you know, whatever quality defects you're identifying, interacting with that defect information, you know, creating, you know, either interacting with existing defects and shortages, or editing the UI to create a new defect that's been identified by the operator. Again, traditionally this would have been, you know, written down on a paper build sheet, but you're capturing all of that information digitally now. We can provide, you know, an interactive experience. So it's not just about recording textual information about what's been identified. You know, the operator can be asked to either do a known inspection of the vehicle and look at certain points, so we can provide visual guides, you know, work instructions on what to do, or they can use, you know, the imagery to actually point and click where a particular issue has been identified on the product. We can also use, you know, the other kind of native capabilities of these devices, such as, you know, the camera, and we'll talk about barcode scanning in a minute. If you want to record a picture of the defect against the entry that's been recorded, you can basically just fire up the camera on the device, take a picture, and then SmartSpace automatically logs both the picture and obviously the textual information that's been recorded to that product that you're interacting with right now. And similarly, we can use, you know, if the device is itself a native like barcode scanner, or even the camera on many tablets can be used to do barcode scanning. And you can use this to, for example, prove that you fit the right part to the vehicle. So any questions about that? Okay, so this is a key idea, because once you've got that core location capability in place, you can start to layer in different applications, using smart space to, really consume that location in different ways. And so this is for example, exactly what Daimler have done. They started on the tool control journey in 2009, and they realized, quite quickly that they could start to use that location information to control other processes such as, digital quality inspections and what they call paperless stamping. And so, the next level from there is, once you actually know in real time where all your defects are on the line, and you've got complete flexibility with how you're using tooling on the line, you can start to, again, in smart space, there's another smart space kind of screenshot, visualize what's happening on the line in real time. And you can see where all your product is, what defects are sitting on top of those products right now. And you can actually start to steer things like online rework. So, you can see here you've got products with particular quality issues. You've got a time counter basically ticking down for how much time you've got left while that product's on the line to actually try and resolve that defect. So Daimler now have roaming rework activities, and they use smart space to help steer this roaming rework activity. And you can attribute all kinds of properties to the objects on the line to help decide which of the rework activities you should actually go after, and which are the ones you're not going to have time to fix in time. But obviously doing rework on the line is significantly a significant cost saving compared to doing rework in an offline or off-tracks environment. So another example, which we did touch on with the tablet, is to do things like part verification. Again, making sure that when an operator says they've fitted a part and they scan the part, they're actually doing it at point of fit on the product. So this is a little example that we recorded a little while ago of this use case. So another thing to point out here, hold on, while that, let me just pause it, is again, this what we call the human-machine interface, the HMI component of SmartSpace, allows you to build any user interface you need to drive operator behavior, whether that's work instructions, it's end-on screens, whatever it is, and we'll see lots more examples of this. But what you can see here is an HMI designed as a set of work instructions for the operator to fit this particular part. And so it's tightly integrated with that spatial model under the hood in SmartSpace. So what we've got is a barcode scanner with a Ubisense tag on it. And you can see this is the underlying spatial model in SmartSpace. So as that barcode scanner is moving back and forth, you can see it's interacting with and coming out of a zone defined around this, this assembly. And so you can see this is actually me, but the idea is the operator has tried to scan the part. He's picked it up on the side of the line. He's got his scanner. He's just going to scan the part, and then he's going to go and fit it. But you don't know that he actually fit that part to the assembly that he was supposed to be fitting it to. So in this case, what we're ensuring is that the part is only scannable when it's actually inside the zone where the part is needed to be fitted. And by scanning it in that case, the system accepts that as a valid scan. So just to give another kind of flavor of examples. So, SmartSpace has all the building blocks to build out, the use cases you've seen, but actually to build you an end-to-end kind of control system where, for one particular customer, this was in a battery assembly environment. We were looking at everything from the real-time work instructions to support, operator activity at each stage of the work process. In this case, it was basically an AGV-led assembly. It was an AGV that acted as the carrier for all the parts, and basically a kit of parts, which would move itself into workstations where an operator was waiting to do whatever they were told to by the work instructions in the screen you can see here. So we'll talk a little bit about kitting a bit later, but SmartSpace also supports your ability to build kits for your sub-assemblies and your products as well. This system also includes tool control, like we've seen, tightly integrated into SmartSpace, where we're actually telling the operator, everything from how many tightenings they need to do through the work instructions, and controlling the torque and batch size of those tools, and even then pulling the torque data off of the tool and there's another whole component in SmartSpace that we've not touched on yet, but the reporting components of SmartSpace to build a historical audit of what happened with those tooling processes over time. So we've got a deep historical record of every step in the assembly process. So this is just a little quick demo of that use case in action.
So what we're going to see in this mini demo is how we can use the SmartSpace digital twin and the spatial properties defined around workstations to automatically identify a product and use that to drive context relevant instructions to operators on the line, whether that's work instructions for standard operating procedures or quality inspection instructions, any context relevant information that operators need to know about relevant to the current process that they are undertaking. And the way we drive that process information to the operator is by identifying these spatial triggers in the SmartSpace digital twin. And here we've got workstations set up for, in this case, a battery assembly process, and we've got AGVs moving around into these workstations where specific work instructions for that particular sub-assembly on that AGV need to be displayed. So if you see I move an AGV into a workstation, we get a spatial trigger for that particular AGV. So what we've got in the background is what we call a SmartSpace HMI. This is a completely configurable component of SmartSpace that allows us to build user interfaces around the customer process that display context relevant information for the operator, that are driven by the underlying spatial events being generated in SmartSpace, and use the rich data model that we have in SmartSpace to ensure that all relevant process information is displayed. If I move one of our AGVs into station, you see that immediately pops up relevant work instructions for that workstation and that particular model that's sitting on that AGV. If I pull that AGV out and I pull a different AGV in, a different set of work instructions is displayed. And these are all configured within SmartSpace, relevant for the combination of workstation ID and subassembly type, and even for the skill level of the operator, we can display different levels of complexity for the instructions depending on their skill and experience. Now what you can see if I pull one of these guys in is we get some specific tasks the operator needs to undertake. We've got visual work instructions, and we've got a record on the right hand side here of the operations that need to be undertaken. In this case, we've got a series of tool rundown operations and barcode scanning to identify the particular part that's being fitted. So as soon as the operator completes a rundown, SmartSpace is automatically communicating with the tool controller, and if we get the correct torque and no errors on the rundown, SmartSpace records that as a successful rundown. Here we're simulating those rundowns. If one particular rundown fails, we similarly record that data against the process, and that can be used retrospectively for any rework operations. And as soon as the operator completes all of those steps, he may well be presented a subsequent set of steps to complete. Once those are completed successfully, the operator can then release the subassembly And in this case, an AGV would carry that subassembly on to the next station.
Okay. So I'm going to carry on through. I'm conscious that we're approaching the last half hour, and there's actually a lot of stuff to get through still. So we'll see how far we get, Andy, and if your team has time, we can always run over a bit if that's convenient. But the last thing I'm going to show you around assembly control is one of the challenges that customers presented us with for a long time when we were working in these tool control problems. We can get pretty granular with ultra wideband as a location system, but often people would say, can you differentiate between two bolts that are, maybe a centimeter or even a few millimeters apart from one another? And unfortunately, with just ultra wideband on its own, it's accurate, but it's not that accurate to that level of reliability. And if you imagine you've got many different products coming down a line, you've got tools all over the place, you've got bolts all over the different models of vehicle coming down the line. Trying to make sure that you're on the right bolt is a bit of a needle in a haystack. And so one of the ways to solve this is to do identification of the bolt you're tightening rather than locating the tool to that particular bolt. And if you can reliably identify the bolt, you can then control that fastening operation down to the bolt level. Now, the challenge, as I say, is you've got lots of cars, lots of different workstations. If you've got hundreds, if not thousands of bolts, which are potential bolts you could identify, how do you reduce the search space? And so this is a great example of how we use smart space to combine sensing technologies and use the spatial information in smart space to create a very efficient control system for this use case. So in this example here, if we were looking for this bolt, I'd be surprised if any of you found it. It's over here. But if I'd given you a green box to start with, to say it's inside here, you would have been much, much faster at finding this. And this is exactly the same for visual identification systems that are using learned patterns of bolts and pattern recognition to find the fastener. So we combine optical recognition technology, which is like the tag which is attached to the tool, also attached to the head of the tool to do the bolt level identification. But we support that system to know, which set of bolts it should be looking for at any point in time by combining it with the spatial registration now that's possible through smart space. And so now, again, we're reducing the search space for the number of bolts, and then that you can make that a very efficient and real-time process to do bolt level identification. And now you can do some really clever things again in terms of not just identifying the bolts, but everything from the sequence control and various bits of operator verification. So I'm going to run another quick video for you to see what that's all about.
When it comes to critical assembly operations, sequence control from Ubisense digitizes the quality control process. Precise wireless sensors detect if a tool is where it is supposed to be, that it is tightening the correct part, and is doing so in the correct sequence, within a millimeter of accuracy. Should the user deviate from the prescribed fastener or sequence, the software automatically and instantly disables the tool and directs the user to the correct fastener. High-performance, ultra-wideband sensors detect where a tool is located on the assembly line and which product or part of the product it is working on. The sensors connect to existing manufacturing execution systems to identify how the product should be assembled. The integrated vision system scans the work area to locate the tool within a millimeter of its actual position by matching the fastener image to a set of pre-learned images. The system identifies the correct tightening sequence and displays the instructions for the user. The tool is automatically activated with the correct settings for use. The system senses where the tool is relative to each fastening. Should an operation deviate from the correct sequence, the tool is immediately disabled to prevent error. Sequence control from Ubisense will only enable the correct operation, no matter how the tool is held, its orientation, or even the environment, correcting for poor lighting or recessed fastenings. Multiple tool activation zones can be created for a single product. This allows the user multiple product variants with multiple tightening sequences on the same production line. The system automatically captures a digital audit for each tightening sequence and sends results to the existing quality system. Sequence control from Ubisense. Error-proofing assembly with fastener level accuracy anywhere in the plant, at a static workstation, on a moving assembly line, or even off the line.
Okay, so that gets us to the end of process control use cases. Any questions about those?
Maybe I might ask a question to the audience.
Yes.
How easily can you relate the things you have seen to your own production processes, in at least those who have in mind, because they are not yet established, I guess?
I guess the simple answer is that since it's my team that are responsible for it, and I don't have my team here because they know where we're going with this, it's very relatable. That's why we're talking to you.
Great. So even the tool, the bolt control level is very relevant to you.
Yeah, tightening sequences will be something we have to kind of deal with. We won't be able to overcome all those issues with step or two-stage tightening. So, yeah.
Okay, thank you. Yeah.
Andy, I'm conscious of time, so there's a couple of different topics we could focus on first and see what we've got left, what time we've got left. So we've got things.
Yeah. I don't know if in the 30-minute I was out, you talked about like part tracking and location from a logistics point of view, because that's something that would be really beneficial for Enrico. That would be my first preference to start with.
Yeah, we can do exactly that. So we'll start with logistics next. Okay. So again, you've seen a little kind of a flavor of some of these things already, but smart space is all around one, understanding how things are moving and flowing, bringing in the right sensing technologies to solve the problem at hand, and presenting the relevant information to an operator to support whatever process they're doing. And so from a logistics standpoint, we do everything from starting with kitting processes through understanding the flow of materials from whatever warehouse or kitting area where things are being assembled to the shop floor and to the point of consumption. So a little example here which combines a couple of different technologies and presents a smart space HMI for kitting operations. Here we've got barcode scanning for doing part identification, but you could also imagine we do this in other customers where instead of actually manually scanning the parts already have an RFID tag on them, and you're basically just picking the part and sticking it into a bin, and there's an under-table reader that tells you what you've stuck into your bin. And here we're showing how we can combine, in this case, barcode and passive and active technologies to give you, both the verification of your process, but also the understanding of movement of those parts through the shop floor. So here we've got a smart space HMI to allow an operator to assemble any of a number of different kits. They've got to pick the right parts out of the bin, and here we're putting those parts into our little container. It's a very small kit that we're building here. So as long as he's picking and scanning the right parts, SmartSpace verifies that that part has been scanned correctly. Here he's picked the wrong part. Still the wrong part. And now he's got all the right parts. So he puts his parts into his kit box. Now here we've got another box that's got an active tag on it. Here's that little black tag that you saw there. And to associate that actively tagged box to the parts that have been scanned, we've actually got, it's quite hard to actually show. There was a different version of this video that I should have found for you guys. But there's actually a passive RFID tag on the main box as well. And we create an association between all those parts using passive RFID and that active tag that we've identified in a particular zone. And now wherever that box that's actively tagged, you can see this is a black, it's actually a Quipper tag on this box, moves in the environment. You can see it moving here in the digital twin in SmartSpace. And as soon as it arrives in the required delivery zone, in this case, we use a spatial interaction to decouple the kit from the container that it's moving in and register its delivery. But of course, that decoupling can be done in a number of different ways. It could be done, again, through using passive RFID reads at the delivery point. It can be done using spatial triggers like you've seen here. It can also be done using a cordless barcode scanner to say, I've delivered these parts to this location. So again, we can bring in any of those different sensing modalities to register the parts delivery. So, this is another example. One of the key challenges, around material fulfillment is making sure that, your ERP system has an up-to-date record of what materials are located where in the plant. And also, supporting, the warehouse and fulfillment operations to make sure they're doing, the optimal next task in terms of materials fulfillment. And so in this example, we're actually tracking a pallet of goods, which is the pallet can have any number of different types of materials on that pallet. And we're providing both a real-time update, basically an SAP transaction to SAP to say, what materials are located in what zones right now. But we're also providing through the HMI components of SmartSpace an interface for people on the shop floor to see what materials are where and where there might be shortages of materials. So it starts with a little explanation, a SmartSpace production logistics control problem. So in many of these production environments, material replenishment processes can present productivity and complexity challenges, as we've said, and often those replenishment requests don't reflect the true physical material movements. And that leads to, in this case, to this particular customer, material starvation and OEE loss on their line. So SmartSpace provides you a real-time view of what materials are located where in the plant. And as you can see, as this pallet transitions out of this defined area, the amounts of materials that we're recording in all these different zones, increments and decrements in real time. So you can see we get a real-time update of the materials, and we're also seeing how quantities of different materials in all those locations. Here we've got a particular set of line feed locations, and we've got 0 materials waiting to be fed into the line in these locations. As those materials arrive, again, you see an instantaneous change in the availability of materials at all those defined locations. And so this information, once again, can be fed directly into SAP, but we can provide these dashboards to users as well, so they can see exactly what's happening on the shop floor at any point in time.
I could, just a question. I could also transfer this this technology to the warehouse in. Let's assume we will have our first tier supplier already kitting for us, and we get the kits ready. I could also basically feedback the system. Now it's going into the plant, this kit.
Yep,
with these.
absolutely. And you can, you can feed not just the idea of the kit, you can actually feed in, what parts are in that kit, for example. Another use case that we haven't got here is, sometimes kits aren't fully assembled. Sometimes the supplier themselves may have a part shortage, but in some cases, a partially finished kit gets delivered, and you want to know where that kit is when the missing part has arrived, so you can actually complete the kit. So that's another example of being able to not just find the kit, but exactly what's in the kit as well. And again, this is where integration is such a key part of Smart Space, because we can bring all of that information to build a truly rich digital twin of your shop floor. So in this particular customer's case, what they really wanted to see, and this is obviously a mock-up of the end result, was they had lots of different types of materials, and you might be able to guess if you look at the left-hand side what kind of a manufacturing plant this was, that needed to be supplied to all these different locations, and the consumption of those different materials happened at different rates, because some materials like leaflets, you can have 1,000 on a pallet or 10,000 on a pallet, and things like the trays or the devices that they were packing, they could only have, say, 100 of them. So things depleted at different rates, and we integrated things like line speed and consumption rate for different materials based on if they were line side, and you could start to see in real time material flow through the plant, where you would have shortages in terms of pallet availabilities to feed to the line. We also even modeled things like how long it took for a pallet to move down a conveyor. So if it left the warehouse, you still would have a lead time to actually get it to the next point in the delivery process. And so you can visualize all this data through Smart Space, and this helps the fulfillment operations to actually see where they're, even though they've got an ordered list of fulfillment requirements, which may have come from the plant, they can actually see by modeling it in Smart Space this way, which are actually the highest priority. So it might be, order number 5 is actually a higher priority than the one that's at the top of the list that they've got right now. So, again, I've just talked about, order fulfillment support, and this is another really key thing that you can do with Smart Space. You've got materials that are required, at different locations in the plant right now, and we can use Smart Space to assign fulfillment activities to operators. And in this particular scenario, this was an automotive plant, a truck manufacturing plant in Asia, where they wanted to see what fulfillments were required. They had a population of forklifts and other materials handling equipment around the plant, and they wanted to dynamically be able to assign the materials handling equipment to the operator. So we start by using Smart Space to actually assign the fulfillment task to the operator. The operator in this case was tagged as well, so you could see where the operator was in the plant. And as soon as the operator, gets into a particular forklift or onto a particular tugger, which is also tagged, and we've got a spatial model for both of those things, we're seeing an interaction between them, like with the tool control use case. We know that that operator has picked that piece of materials handling equipment. And that then, on each of those, like inside the forklift, there's a screen that says, okay, this task is assigned to this operator, and that pops up on an HMI. This is your fulfillment task. And it gives them a map, unfortunately it's a bit hidden in here, of where they need to go to pick up those particular parts, the identification of those parts. And when they arrive at their location and they've picked up the parts, they can approve on a button on the screen, say, hey, I've picked up these parts now. And then that changes the map view to say, okay, now you need to deliver them to this location in the plant. And so they drive off, and when they get to that delivery point, we measure, has the forklift arrived at the right location? Have the parts been delivered, like we saw in the earlier use case with the kitting, to the right point of use? And only if they've delivered the things to the right location can they then approve that they've completed the delivery task. And then that then updates the work instructions to say, okay, now deliver your forklift back to this location, or here's your next job in the queue. So they can choose how they want to, handle that. So there's a whole, closed loop control system for how order fulfillment is managed using SmartSpace. And the other really interesting thing that we do there is we're also measuring the utilization of those bits of materials handling equipment. So because we've got all these different discrete stages in the process that we're controlling and measuring, we can see how much of the time, for example, they're actually spending, collecting the goods that they've been assigned, how much time they're doing, actually transporting the goods through the delivery process, how much time they're waiting to actually do drop-off, and how much time they're spending returning, for example. But again, we can model this any way that the customer wants to. This is just an example of that specific environment. So again, this is an example of where there's a lot of data in the background that we're actually recording historically, in addition to the kind of real-time control stuff we're doing. I'm not going to cover this use case. We'll have the slides because I'm just interested in time. This is another interesting one where rather than tracking the totes or the crates, in this particular customer's case, they had passive RFID on the crates themselves and readers, passive RFID readers mounted onto the forklift. And again, this is something that we do quite widely, and we have an active tag on the forklift itself. Usually an ultra wideband tag, because you want to get high precision location of where everything's going, and often we actually put 2 tags onto the forklift so we can measure the orientation of the forklift as well. And so now we can reliably measure exactly where the forklift's going, and through passive RFID we're associating that crate and those parts to that forklift. And now we have site-wide visibility of any materials movements around the site. But we've only got, and the beauty of this is we've only got passive tags on the totes and the crates themselves. So that's one way of doing large-scale kind of materials tracking using low-cost technology like passive RFID, but in a clever way coupling it to more expensive active technologies using that combination of sensing technologies. And then I think this is a last example just to kind of touch on logistics. Another challenge that we've seen in customers is where you've got lots of fulfillments happening together and in parallel, and you've often got fairly in relative terms narrow aisles for materials handling equipment to move down. And if you've got a long tote truck or a set of forklifts that are trying to deliver to similar locations, you may get basically traffic jams in your plant. And so this is another great example of using the spatial model in SmartSpace and the intelligence in SmartSpace to model what is happening with your delivery processes and who is likely to get in the way of who based on the set of orders that you've got right now. And so in this example, what we're showing is that from the warehouse where we've got a number of fulfillments that need to be completed, we can actually reprioritize based on who's already out there delivering what and who's likely to block any of these other orders that are waiting to be fulfilled. And so we can either tell operators to fulfill a different order, which is not going to, be impacted by one of these other delivery locations, or we can just steer them to the one that is the most likely to get delivered based on the time, the average time for delivery of these particular parts at this particular location. And again, when we're delivering a system like this, again, we're not just doing the real-time control, we're building up a historical record of how long it took to do every step in the process. And so even down to delivering these parts to these locations, we'll have a statistical model of how long that typically takes. And we can build that into our prioritization to say, okay, this one's probably going to finish in the next 5 minutes. It's going to take you, 2 minutes to get down the line. You'll only have a 3-minute wait, for example, compared to sending B or C, who might have, a much longer wait, depending on what's happening upstream.
You just one question. You mentioned that everything is also shown through an HMI to the operator. This is also then applicable if we would have automated guided vehicles, then the interface is just with a HGV, right? and
Yeah,
they
yeah, so
can
actually,
communicate these
yeah,
two.
so I actually had a slide on that somewhere here. I'm getting lost in all my own slides. Where was the stuff on AGVs? I was under the worker safety stuff. So yeah, we can. So this was in the context of worker safety. So this was a project you may have heard of, Daifuku. This was a system that we've deployed with Daifuku in the past, where again we're using an understanding of where all the moving equipment and AGVs in particular are located in the plant, and making sure that those AGVs don't collide with people and other equipment that are moving. So again, we're tracking people, and so that we know who's likely to be interacting with who. But we can absolutely, use the same concepts to drive other AGV behavior, pickups, drop-offs, all those kinds of things. So the location stream is a fantastically reliable source for AGV navigation. How are we doing on time? We've got 5 minutes left. So we haven't managed to cover everything I'd wanted to, Andy. There's loads of process monitoring use cases we haven't covered, tooling and asset management, worker safety and, compliance related things. So
a lot of that kind of falls under there. I guess I wanted to make sure that Enrico had seen some of the logistics applications, and obviously the IT guys had seen where my thought process is coming. A lot of the stuff you've got extant is for like my responsibility anyway.
Okay.
Which means I've got a slightly better handle on it because I've got exposure to this. I guess the key here is that the key message I'd like the team to take from this is that nothing is impossible if we can think about it.
Yeah.
The application of it is so versatile that if we look at the advantages it can give us, I'm sure Enrico, the other guys will go away. They'll suddenly think, I wonder if you can do this. I wonder if you can do that. And that will lead to the follow-up on this. But that's why we've got the initial development kit on site at Lilium. That will be the start point of this journey. But it's just a flavor for me. I think what we'll end up doing is doing some little specific stuff with other groups to bring everybody into this core technology.
Yeah, makes complete sense. And as you can see, as Andy says, it is so flexible. The way often what I say to customers is, if you can describe it in, I usually say, if you can describe it in English, we can configure it. But whatever your mother tongue is. But the point is that it is a platform that is so moldable to so many different processes, and because it's so mature, we've got all of the different tools in the kit bag to configure whatever you need around your process. And the beauty is, so it's a bit of a process control layer, but also you're getting the benefit of all that sensing data coming into the platform as well. And a lot of what we've talked about today is using location and identification sensors, and that's really what the platform has been built for. But the system is not constrained to using that kind of sensor data as well, because actually what you might call one-dimensional sensor data, temperature, humidity, vibration, all that kind of stuff, that's really easy data to manage. And we do integrate that technology, and again we build that into the model as well, and that gives you additional context to what's happening in your environment. So again, don't be limited by anything except your imagination here, and we will work with you and support you to prove the viability of these things for your use cases.
So I mean, any last little comments from the team? Any quick questions while we've got John here and the guys?
No, from my end, nothing. It's a very good overview, and really happy to see that. Obviously, we need to get one level more detailed on the IT architecture topic and everything, but that's the next step. But for today, this is definitely
great.
Thank you.
Yeah, absolutely. We can dive as deep as you like on the IT side.
Yes, thanks also from my side. Was really interesting.
Great.
So Enrico, when I told you just trust me, are we a little bit forward on that?
Yeah. It's a very nice technology. Yeah.
So Andy, what do we consider next steps then? So I think, we were talking about getting some photos of your mezzanine laboratory area to start planning out a sensor system deployment.
Yeah, so we'll have two things. So tomorrow I'll be on site. We'll take the pictures. We've already got one of my engineers has drawn up the mezzanine area. It's not complicated, but it just shows you what we're planning. And how we want to use it. Then I think the other next step is for me to have some feedback sessions with the guys. And then I think the next step is setting up some targeted audience little mini sessions. So one on IT, I'd like to get some of the quality guys in so they understand my thinking on tool control and process control and that side of it. Enrico will go away, think of some concepts, some ideas, some questions, and then we could do a focused logistics one. That's how I kind of would like to do it. But if the team have got views as well, then I'm more than happy to take that on. But I'll discuss it with them, and then I'll come back to you and we'll set some stuff up.
Okay, sounds great.
Does that sound like a plan, guys?
Good.
Yes.
Sounds good.
Yeah, good.
All right, good. Well, I think I went way over time myself, but I think we're okay to wrap up for today then.
Yeah, so just a big thank you from me, just for setting this up, taking us through it, and also a thanks to the Lilium team for supporting this. It's important. It's going to really underpin a lot of our facility and operational infrastructure. So it's really, really good to have you all guys all here and supporting it. So thank you.
Yeah, thank you guys very much, and we're looking forward very much to get to know you and working more closely with you on this.
Thank you.
Thank you.
All right. Ciao, ciao.
Bye.
Bye.
John,
Everybody.
John, do you just want to stay on for a second?
Yeah, absolutely.
Yeah.
John, I'll call you later then, no?
You can stay on if you want as well.
Okay, fine. Then it's fine.